Okay, so in this video, we want to find the equation of a graph. So up until this point, we've looked at sketching linear graphs. So given the equation, draw the graph. What we want to be able to look at today is if you have the graph or information about the graph, can you find the equation? Okay. So when we find the equation of a line, there's two possible forms of the equation of a line that we might choose to use. You can use gradient intercept form, and in my experience, students use this all the time, when I actually think that point gradient form works better more often than not. However, both will work in all cases. However, I would only use gradient intercept form when I have the gradient and the y-intercept. Most importantly, the y-intercept. If I'm given the y-intercept, absolutely I'm going to use gradient intercept form because I can pretty much write the equation down straight away. Whereas if I have gradient and a point that is not the y-intercept, I would use point gradient form, this form on the right-hand side of this table here. Okay, so point gradient form is simply just a rearrangement of the gradient formula. So gradient is change in the y values over change in the x values. Sorry, this one. Now, if instead, so normally, gradient's what we're trying to find and we know 2 points. If instead we know the gradient and we know one of the points, we leave those values as x and y. They're the x and the y in the equation. When we then multiply, get rid of the fractions by multiplying by x minus x1, that becomes m times x minus x1 equals y minus y1. So it's just simply a rearrangement of the gradient formula. The advantage is when the point that you have is not the y-intercept, you don't have to do lots of steps, extra steps, which you do with y equals mx plus c. You straight away insert your gradient in place of m, insert the coordinates of your point in place of x1 and y1, and then away you go. Okay? And then you simply just rearrange, tidy it up and rearrange to make y the subject. I want you to try this. I know it's not familiar, but I want you to have a go at using it because I think you'll find it's really efficient. I find lots of students get to year 11 and 12 and they've never seen that and they've never tried it because they just stick with this all the time because they know it and it's familiar. But I want you to have an experiment. If you play around and you do the point gradient form and you really don't like it and you want to do gradient intercept form every time, fine. Okay, but at least make that decision having tried them both. Okay, so let's have a look at some examples. Find the equation of the line with a gradient of 3 that passes through the point 0, 7. Okay, so we've been given gradient, so our gradient is important and we've been given a point. And the important thing to notice about this point is that that is a y-intercept. Okay, if the x value is 0, that is a point on the y-axis, so that is the y-intercept. So we've got y-intercept and gradient. Straight away we've got gradient and y-intercept, and so immediately we don't need to do any calculations. We're going to use gradient intercept form and we can write down the line, equation of the line. So y equals 3 times x plus 7, which is the y-intercept. No calculation required. Even if, I should also say this little box here, if it doesn't specify what form you should give the answer in, I would say it's conventional to simplify your answer into gradient intercept form. That doesn't mean that it's always easiest to start with gradient intercept form. If you start with this form, you certainly wouldn't leave it in that form. You would then simplify and expand and rearrange to give gradient intercept form. Okay, let's have a look at example 2. Find the equation of the line that passes through the point 1, 3 and has gradient of negative 2. Okay, so we've got gradient and we've got a point that is not the y-intercept. So this will be x1, y1. Okay, so I'm going to use gradient point form. I'll show you that you can do it both ways, but I'm going to use gradient point form. Y minus y1 equals m times x minus x1. So subbing in our point, x1 and y1, okay, so y1 is 3, so it's y minus 3, y minus the y coordinate of the point, equals the gradient, which is negative 2, times x minus the x coordinate of the point, which is 1. Okay, so we've now put all our information straight into the equation. We can now expand out the right-hand side, which gives us negative 2x plus 2, and then make y the subject by adding 3 to both sides. So negative 2x plus 5. There's our answer. If you use y equals mx plus c, okay, you only have the gradient, you don't have c, so you can put negative 2 in place of the gradient. Then you're going to use the point. So you're going to sub the point 1, 3, which means when x equals 1, y equals 3. 3 equals negative 2 times 1 plus c. You're going to solve for c. 3 equals negative 2 plus c, so c equals 5. And therefore, then you can sub that back into your equation to get y equals negative 2x plus 5. You get the same answer. You get the correct answer. I just don't like how bitty it is. You put the gradient in, then you sub the point in, then you solve for c, then you put it all back together in your equation, okay? Whereas this one, whereas the first version that I did, you put all your information in straight away, and then you're just rearranging to make y the subject. I find it's a more streamlined process in that way, okay? As I said though, both work equally well, and if you want to use gradient intercept form every time you can, but I want you to have a play around and give this one a go. If you've never done it before, give it a go and see what you think, okay? Alright, example 3. Find the equation of the line passing through negative 2, 5 and 0, 3. Okay, so this time we haven't got the gradient, but we have got 2 points, and so we can find the gradient using those 2 points. We also notice with our 2 points that one of those is the y-intercept. So I am going to use y equals mx plus c once I've found the gradient. So we need the gradient first. Gradient is going to be rise over run, change in the y values over change in x values. So I'm going to do 5 minus 3. So because I've done 5 minus 3 on the numerator, I have to do negative 2 minus 0 on the denominator. So it's 2 over negative 2, which is negative 1. So gradient is negative 1, and the y-intercept is 3. And so therefore the equation is negative x, which is negative 1 times x, plus 3. You can use this point to find the equation of the line. You would get to the same equation in the long run, and I would probably use gradient intercept, I'd probably use point gradient form. But it's going to take you a lot longer. So you want to look to recognise, do I have the y-intercept? If I do, absolutely y equals mx plus c is the way to go. Okay, question 4. Given the following table of values, determine the linear equation relating x and y. So it's important to understand that this table of values is really just giving us 2 points. When x equals negative 4, y equals negative 2, and when x equals negative 1, y equals 7. So we've got 2 points. Neither of those points is the y-intercept, so I'm not going to use gradient intercept form. I'm going to use point gradient form. Either way, I haven't got the gradient, so that's the first thing I need to calculate. So gradient is rise over run, change in the y value, so I'm going to do 7 minus minus 2 over change in the x values. If I've done 7 minus minus 2 on the top, I have to do minus 1 minus minus 4 on the bottom. 7 minus minus 2 is 7 plus 2, which is 9. Negative 1 minus minus 4 is negative 1 plus 4, which is positive 3. So 9 on 3, which is 3. So we've got a gradient of 3, and then we've got 2 points. You can use either of them. Y minus y1 equals gradient times x minus x1. I'm going to use this point. You can use the other one as well. In fact, I'll do it twice and I'll show you that you should get the same equation with both points. So y minus the y coordinate of the highlighted point, so y minus 7 equals my gradient times x minus minus 1, so it'll be plus 1, which is the x coordinate of the highlighted point. And now I'm just going to expand out the right hand side, 3x plus 3, and add 7 to both sides to get y on its own. So that's the equation. Or we could do y minus y1 equals m times x minus x1 and use the other point, which is y minus minus 2, so y plus 2 equals our gradient, which is 3, times x minus minus 4, which is x plus 4. So we get y plus 2 equals 3x plus 12. Just expanded out the brackets, subtracting 2 from both sides, 3x plus 10, which is the same. Okay, so it doesn't matter which point you use. Again, you could also use gradient. You could also use y equals mx plus c. Put in your gradient first, which is 3x plus c. Then sub in your point. So if we put the point, was it negative 1, 7? You're going to get when x equals negative 1, when y equals 7. So I've subbed in the point, solve for c. 7 equals negative 3 plus c. So c equals 10. And then putting that back into the equation. Same answer. Okay. Or we could do y equals mx plus c with the other point. So it's y equals 3x plus c. If we instead sub in the point, what were the other coordinates? -4, -2. Y is -2 when x is -4. -2 equals -12 plus c. Adding 12 to both sides, c equals 10. And so therefore equation is 3x plus 10. 4 different perfectly valid ways that all get to the same answer. I am not asking you to do it 4 times, I'm purely demonstrating here that the 4 different, whether you use point gradient form, and no matter which point you use, you're still going to get to the same answer. Similarly, if you use gradient intercept form, whichever point you use, you're still going to get to the same correct answer. Okay. Alright, example 5 here, which I think is the last example. Yes, let's have a look at a worded problem. Kyle invests some money in a simple savings account and the amount increases at a constant rate over time. So if something increases at a constant rate, it goes up by the same amount every time, means graphically it's a linear graph. Okay, constant rate means that we have a linear graph. Kyle hopes to buy a boat when the investment amount reaches $20,000. After 3 years in the amount, after 3 years in the account, I've written in the amount in the account. After 3 years in the account, the amount is, it's not a very good sentence, is it? After 3 years in the account, hang on, that's not where the word's missing. After 3 years, there just shouldn't be an in there. After 3 years, the amount in the account is $16,500. After 6 years, the amount is $18,000. Find a linear rule linking the investment amount and the time to years. Okay, so linear rule y equals mx plus c, but it's not going to be y and x, it is going to be about time and amount. Okay, time is the independent variable, amount is the dependent variable. The amount in the account depends on the time. So that's going to be the form of our equation. A equals mt plus c. Okay. Now, we've essentially been given 2 points, okay? We know when t equals 3, a equals 16,500. We know when t equals 6, a equals 18,000, okay? So this is the point 3, 16,500. This is the point 6, 18,000. 2 points on the graph. So we can find the equation for the line. This could have no context whatsoever, and it could just be find the equation of the line that passes through these 2 points. That's all the question's asking us. And that's the key thing you've got to do in worded problems. Okay, you've got to work out, how do I reduce this down to just a very simple problem that's got nothing to do with the context? And in this case, that is find the equation of the line joining the points 3, 16,500 and 6, 18,000. So we've got 2 points, so we're going to need the gradient. Okay, so gradient is going to be, so I'm just going to get rid of that general form from there for now, because I think things are going to get a bit crowded. If you've written it there, that's fine, don't worry. I'm just going to, oops, sorry. Just going to move that over there. Okay, so let's get that down a bit. Okay, so we know that our, struggling. Okay, I think I'm nearly there. Okay, so we know that our linear rule is going to be in this form, but we'll worry about that at the end. Okay. If you prefer to just work with y and x while you find the equation, that's fine. You can think about this as x equals 3, y equals 16,500, x equals 6, y equals 18,000. Okay, so it's going to be equals mt plus c. Okay, so let's find the gradient first of all. Gradient is going to be rise over run, change in the y values, in this case change in the a values, over change in the time, change in the x values. Okay, so that is 18,000 minus 16,500 is 1,500 over 6 minus 3, which is 3. 1,500 over 3 is 500. Okay, that's the gradient. That's the constant rate that it goes up by each time. For every one step across, we go up by 500. So it's going up by 500 each year, $500 each year. So then we can either use our gradient intercept form or our point gradient form. if we do gradient intercept form, we're going to have A equals 500t plus C, and then we can use one of these points to find the value of C. So we can sub in, maybe I might go with 18,000, just because the numbers are a bit smaller, a bit neater, sorry, not smaller, they're bigger, but the 18,000 I like better than 16,500, but it's up to you. Okay, so I'm going to sub that point into this rule. So when A is 18,000, T is 6, sorry, so it's going to be 500 times 6 plus C, 18,000. I know they're big numbers, but they're not horrible numbers. 500 times 6, 5 times 6 is 30. 500 times 6, therefore, is 3000, so 3,000. And then C will be 18,000 minus 3,000, which is 15,000. And so, therefore, our equation is A equals 500t plus 1,500. Okay. Again, you could have used gradient intercept point gradient form, so you could have done, so it wouldn't be y, it'd be A minus one of the y values, so 18,000 for example, equals your gradient, which is 500 times t minus the x value of that same point, and then simplified it down to this point, so whichever you prefer. Perhaps in the application problems it's a bit easier to remain clear with what's happening to use your gradient intercept form, but both will work. How much did Kyle invest initially? Okay, so initially is when t equals 0, after 0 years. So the amount is 500 times 0 plus 1,500, and so when t equals 0, actually I'll just write that as A equals 1,500 and then answer the question. So therefore he invested $15,000. How long will Kyle need to save? So what is t, how many years before he can buy his boat? So we know that he's waiting for the account to get to $20,000. So again, we've got our rule, A equals 500t plus 15,000. Our rule connecting t and A, the time and the amount. This time we want to know what the time is when the amount is 20,000. So substituting A equals 20,000 into the equation, and we want to solve for t. So subtracting 15,000 is 5,000 equals 500t. And then t will be 5,000 divided by 500, which is 50 divided by 5, which is 10. So therefore, it will take 10 years for him to save $20,000 in the account, for the account to grow to $20,000, and for him to then be able to buy the $20,000 boat, which probably in 10 years' time will be worth $30,000. So perhaps he needs to aim a little higher. Anyway, again, there's an older video linked here, another video going through finding the equation of a line if you've got gradient and a point or 2 points, if you want another explanation. But really today we just want to get straight on to exercise 1G, and there is the list of questions.